Hello, everyone. Thank you for your interest in this webinar. In the Peeking Beneath the Surface, on today's webinar, I'm going to talk about video streaming on the internet. All right, and so let me go over a couple of things here, and I'll answer any questions that come up at the end. So I'm doing this under SKC Science and Technology webinar series. You can find out about future webinars or past webinars on this website that I'm maintaining. So let's see that they're basically, I'm going to think from three pieces of for this presentation. I'll talk about standard video streaming. Then towards the end, I'll cover 360-degree video streaming, which is a very interesting and exciting thing happening soon. And then what's research in video streaming means? So I'm going to touch that as well. I want to acknowledge a few people here. Parikshit Juluri, my student, former student rather, Sheda Kiani Meher, Hema Yarnala, Shuai Zhao, and Professor Venkatesh Tamrapalli of IIT Guwahati, with whom I have collaborated on many work related to video streaming. So basically, think about like you wanted to watch a movie online, and so I call it, let's get some popcorn, right? So for example, you want to watch a movie on Netflix or Amazon Prime or Amazon FIRESTICK. So what you will do is that when you start the movie, it says that it's buffering and will say X% complete, and eventually it will say 100% complete, and the movie will start. So when it is buffering, that's what I call it the popcorn time. That means you go get something that you want to munch on during watching the movie. So usually what happens is the movie quality seems to start very well. And sometimes what happens, you will notice that the quality has suddenly dropped and you have no idea why it did. And it looks like it's okay again, and it came back. So you then try to wonder, okay, is it going to stall? That means the movie is not going to move forward at a certain point. And so usually you don't want that to happen if it is like most thrilling part of the movie, right? So that's something you kind of worry about. And so that's sort of the thing that you face when you are what is called streaming video over the internet. So I'll tell you why this happens and what are the mechanisms that's used to be able to minimize or avoid or eliminate these possibilities. So now think about also watching a live event, TV event, like a sports event online, and you can see quality also drop once in a while. So the basic mechanism for live streaming online is not too different from how a movie is done for a recorded movie to play it out. So the question is that why does the quality drop and how does the video streaming actually delivery works? So that's what I kind of go looking under the hood or beneath the surface, as I say, and to find out what you can learn about this. So before I go to video, let's quickly revisit web transfer. That means just a web page file transfer. What happens with that? What are the basic mechanisms? So consider this web page is my web page. There's no basic information in there. I want to transfer the main page from this website. How does it work? The client, we use two terms you will very commonly use in computer or networks or rather internet you'll see, a client and a server. Client is your mobile device, your tablet or laptop, your desktop computer, and it can be even a smart TV, that's a client. A server is where the data resides that you are trying to fetch from. So the protocol that is used for the web is called HTTP, and it stands for Hypertext Transfer Protocol. And so what happens is that with this protocol, the request for this particular home.html page is actually going to look like this from the client side. And this is something you as a user or me as a user do not see. So you have to kind of look underneath, get that information. There are tools to be able to track it and get it out. So what you'll see is the client side will say the get space, there has to be a space, then the name of the file, space, http/1.1 /1.1, which basically means that it's going to use the HTTP protocol that I mentioned to a second ago, and it's going to use the version 1.1. In the second line, you'll say host colon space, and then it will give the domain name. You know the domain name, right? So this is not typically called a domain name. Remember, the host doesn't mean the client. Host means the server, that where you're going to go. Third line is very interesting. It says the user agent. It will say something like Mozilla /5.0, and there's a few pieces of information. I'm not printing it out here. Keep this one user agent in mind, and I'm going to come back to that later, talking about video delivery. The server side, if the page exists, is going to respond, and in its response is going to sort of compose of a few pieces of information. First line will be confirming that protocol is indeed HTTP 1.1, the server is responding to. 200, okay, both means the same thing. 200 is the code, okay is the English word for okay, for this HTTP protocol. Second line is the date, what it is. Third line is the server. The server doesn't mean the domain, the location of the server. Here the server means what is the server implementation version it is using it. It could be an Apache server, or it could be a Windows server. That's what is indicated. Next, it is going to say what's the last modified date for this. This piece of information is very important, because this tells client that if the data is old or not. Then it follows by a line called content length. Content length, it will have a number. In this case, you'll see 1764. You may wonder what 1764 is. This information is in bytes. And you have heard the term megabytes and gigabytes and whatnot. And this is just purely bytes. So this is even, that means it is 1,764 bytes, mean less than 2 kilobytes, very small page. And this actually refers to the page of home.html, that this is how many bytes is going to contain in that. Content type tells it is a text.html. That means this page is an HTML file, and it's going to do the connection close, and then means it's going to close the connection, but it is going to attach then the home.html file at the bottom of it. So what your client is going to do, client, whether it's a browser, whatever you're using it to look at it, it's going to actually, delete this information and uses it for verification, only use the content of home.html. Good. So keep this thought in mind. You got a client, it could be a mobile device, tablet, or what it is using HTTP protocol, has a certain format it needs to follow, and then server responds with a certain format so that it knows how to parse the data to display what is needed to be displayed. Quickly, I want to point it out. If it is a content type is, let's say you are trying to transfer a picture, an image. Images are JPEG file. Content type is going to say, hey, this is a JPEG file. That's what is going to be indicated through that. So why this is important? That this is important because when the client gets it, clients know how to interpret that piece of information that follows that for the content type. So we usually say there are three pieces of information that's very important: the content length, content type, and what is the actual content. These three pieces of information tells you a lot about what the client browser is going to do in terms of displaying it. So now let's look at how long it takes to transfer a file. So just to illustrate it, what I'm going to do, to use an example, but to us it looks like fairly instantaneous. Sometimes it looks like a slight delay, a few seconds. So just let's get a sense of what it is. So the best way to look at this is by looking at just some simple numbers, right? And in order to do that, we look at the very simple way to look at that information from calculating it is. The time to download depends on the size, page size. In the last example, I showed you 1764 bytes. And what is the transfer rate, average transfer rate you got to transfer the page from the client to the server, back to the client sending the request, server sending it back to get to you. Good. So let's look at some numbers. So for an example, I look at this particular website. It says the average web page size right now is a 1.4 megabytes. In that sense, my home.html file is very small. Okay, you got the idea, right? Just to illustrate, I'll assume the transfer rate on average is 5 megabits per second, which we typically in the short form write as Mbps. So if I divide this to number, you have to realize one important thing, that I'm giving the rate in megabits per second, which is the common way to always write for transfer rate. But contents or pages or images, we always talk about in megabytes. For those who are not familiar with is that 8 bits makes a byte. So when you're doing this calculation for using this formula, I have to take into account that I make sure that the bytes and bits are all lined up properly to calculate it out. And once you do that, you find out the time to download this 1.4 megabyte of a page is going to take 2.2 seconds, which is not very long. It can actually, it takes very quickly, you suddenly see it. Now let's consider a video transfer. First thing is the files for a video are much larger, right? So, and I'm going to illustrate what do I mean by larger here. Let's consider YouTube video. You're very familiar with YouTube video. And I kind of looked at this particular website and it always has information about what it is. Sorry. It says that average video length is 11.7 minutes. That this is about less than 12 minutes. And if you look at what is called a 480 pixel video, and for per minute is going to take between, to code that information is going to take between 8 to 11 megabytes. Good. So then if you multiply the average video length with this information, that means the video file size is going to be somewhere between 93 to 111 megabytes. Okay, so roughly 100 megabytes range. So compare that with the average web page size of 1.7 megabyte. That means this is already an average YouTube video is already 2 order of magnitude larger in terms of the size. Good. What about the full-length movie that you want to see? The full-length movie, what we find out is if it is using the standard definition 48 pixel coding, is going to take about 1.5 gigabyte for standard definition. So if you're not familiar with megabytes to gigabyte, 1000 megabytes makes a 1 gigabyte. So remember that, okay? So this is actually, again, already the 3 order of magnitude, sorry, not three from the YouTube movie point of view, it's 1 order of magnitude higher, but from a page point of view, it's a multiple order of magnitude higher. What about a high definition movie, 720 pixel? It is going to about for a regular full-length movie, it's going to be roughly 4 gigabytes for the high definition movie. So let's now use the same formula that we used before and see what we get. How long does it take to download it? So remember the formula, time to download, and then size and transfer. So you find out that I'm using the YouTube average size to be 100 megabytes, assuming the same 5 megabit per second transfer rate is going to take me 2.67. That means the entire video to take time is 2.6 seconds. Standard definition movie, 40 minutes. 4 gigabyte movie, 106 minutes, over close to 2 hours, right? So if you are thinking about like transferring a page, I'm going to get impatient by the time it takes this long to transfer the entire information for it to play to you. So the whole idea about regular web doing HTTP doesn't work. So what we learned is that Video Center cannot work like the way we do web pages. It will take a long time. So we need a new mechanism. This mechanism is called DASH. DASH stands for Dynamic Adaptive Streaming over HTTP. And it's a standardized thing done by MPEG. MPEG is the Motion Pictures Experts Group. They standardize anything related to movies. And so what it has done with the DASH is that it's going to go over HTTP, that we know for sure. But what they're going to do is that the entire movie, they're going to break it out into small pieces, small media. And that will be transferred one at a time. Second thing is that each of these media small pieces, it's typically known as a video segment, is going to be for a certain fixed duration. For example, it could be 2 seconds long. So think about a movie that is, let's say, 2 hours long. If it's a 2-second long clip or a segment, that means 1 minute you're going to have 30 segments. And then for 2 hours, you're going to multiply that by 120 minutes. That many segments it's going to have. But you are breaking it down in a certain way, all right? Secondly, even for each of this video video piece, it is not coded or provided only in one resolution or representation. It's given in different quality of information. So what happens is that now we can think about like a table of information. One way you are looking at it is like you got segment 1, segment 2, segment 3, like however many, let's say segment 100. That's for resolution, the highest resolution. Next row of the table is like the medium resolution, segment 1, segment 2, segment 3. Third one is low resolution, segment 1, segment 2, segment 3. So I'm giving an example as if you have a 3 different resolution, highest, medium, and low. I'm aware of videos that has been, that's generated that can have a 20 different representation, for example, or resolutions. And then what you do is you allow the client to be the driver, essentially. And the server, that means whether you're watching your YouTube on your mobile phone or a laptop or a tablet, is going to be driver. It is going to say that, as the server say, hey, give me this segment at that resolution, okay? And that's based on what is the current network condition. How does the client know which segment to fetch and which resolution to do it? First, remember I said about the table. This table of information is kind of stored in what is called an MPD, or media presentation description file. And it contains the full video description. I'll come back to that in a second. So this is actually almost like a web page, this MPD file. Good. It's actually done with XML, but it's an MPD file. It's on a web page. The first time your client is going to do is fetch this file. And as soon as it fetched it file, it is the whole table of information of different resolution and segment. And then based on the network condition, it's going to say, hey, give me the segment number 7, resolution, the lowest resolution. Segment number 8, give the medium resolution, like that. You'll keep saying. And server acts like a dumb instrument, is going to respond whatever they are asking. And all of these segments are basically like almost like a web page link that's embedded in the MPD file. Okay, good. So to make this work, understand that both the client as well as the video server has to be dashing compatible. You cannot have a fairly dumb client that fetches a regular web page. It is not going to work it out because it doesn't know how to interpret once it fetches the MPD file, what to do with it. Then because it is always doing fetching different segments and whatnot, it's almost like going back and forth, almost like a ping pong. Clients is saying, hey, give me segment number 7, resolution, lowest resolution segment 8, medium resolution segment 9, high resolution, like that, right? So client is doing it. So remember I said that why you need to, why it may select something of different resolution or different quality is because that the condition of the internet changes. Okay, so if you're watching a 2-hour movie, roughly it's going to transfer everything. It will take roughly 2 hours. We know that. But what we did is that we break up the idea into segments so that make it viewable. Okay. So what you do is that change in the available network capacity between your client all the way to the server, whether you are watching the client on a cellular network or at home on a cable service, doesn't matter. It goes through typically through the fiber optic core network all the way to where the servers are located. That could be across the country or across the globe that you do not know always often. So during the time of something you're watching, the number of users changes, number of what the users are requesting changes. That means because of that, they think about this like a road that between the client and the server, that the capacity of the road, what is available, the congestion keeps changing, almost like a road. Secondly, there can be peak hours, like road network has peak hours, like in the morning, during office hour, and at the end of the day when office hour is over. So for that also you have to do it, The other thing that is happening is that, especially with mobile devices, we take the device and watch it. I might be on a train, or I may be on a bus or a car. I'm watching some event there. So that also gives the perception to the user device that your bandwidth is actually changing all the time. So I'm going to give you a couple of illustrations. This is based on a paper that I listed at the bottom. So this researcher actually did a study to understand how the available bandwidth changes as they try different environments. The first one here example is a ferry. It is going from, it's in Norway, the country Norway, doing Oslo ferry route from Nesodden and Aker Brage. It's from this tip here, and it's going to get to there. You can immediately understand that if it is doing it through a cellular network, the cellular network signal is going to go down as you get farther away from this tip. And then it's going to be low, and then it's going to try to catch signals. It could be, if there are towers there, it may cancel some here, may again slow down and whatnot, right? So this is an example of what happened there. So you can see that the black line here is the average bandwidth, the measured bandwidth they noticed. And this gray area, basically what is known as they did multiple measurement at each point. So there's always going to be some amount of fluctuation. So you can build what is called a confidence interval. That means how much the bandwidth is changing. In this example, they're writing in kbps. Your number is given in 4. That means about 4 megabit. This one is about between 2 and 3 megabit per second. It going down to almost 0 here. Again, back up to 2 to 3 megabits or so. Okay, and this is basically represent that this is where it is. Let's look at another example. Here's a train commuting. Train can go from one cell tower to another one in terms of when your phone is catching the signal. And so it can fluctuate quite a bit. And this is what this is showing in terms of the fluctuation and over here and whatnot. Another example, this is an example of a bus. Again, all these 3 examples are from Norway. And here you said the fluctuation happened, but not as fast as a train, because buses are not going as fast as a train, right? And also, metro areas, or depending on what it is, certain areas you might have more towers, cell towers that give signals, so it continues. But even then, you can see the bandwidth is actually changing. And okay, so this is very interesting to kind of know about that. So if the bandwidth is changing, then you have to do something about it to be able to do it. So let's see what happens at the client as network conditions change. It doesn't matter what it is. So here's the video generated by Sheda Kiani Bihan. We actually simulated the entire thing, and I'm going to play it out, okay, and see what happens with that. So first, I want to point out that this particular video, I have the resolution from bitrate from 200 kilobit per second all the way to 12,000 kilobit per second. Earlier, I talked about high definition. High definition is 720 pixel, which is 4 kilobit per second. Now there's even higher definition possible. 8,000 kilobit, which is 1 kp, sometimes called 12,000, and there's something called 4K. 4K pixel also is becoming. In this particular one, each segment is of 2 seconds. And I'm going to now, this is a Big Buck Bunny video. It's a little over 2.5 minute. Hopefully you can watch a couple of important things as it is happening. First, you're going to see this all the time. 1080 means that pixel I talked about. Okay, 8,000 is the kilobit per second, and 30 frames per second. FPS stands for frames per second. What is known is that for our human eye, if it is 30 frames per second, we see everything as a continuous. Okay, and so that's very, very important to be able to realize that. And so, and then what you wanted to then look at is that these numbers are going to change, not the 30 frames per second. This is for continuous. Frames, it is going to count in terms of frames. If you think about 30 frames per second in terms of digitide, that's basically when I have a frame, I have another frame, I have another frame, there are 30 frames. That means each frame is 1/30th amount of time. Think about, so actually time is discretized, we call it. And then it is going to record the information. So I'm going to play it out, keep watching it. It doesn't change at the beginning, much of this information, I'll tell you where it changes and where it stalls. I'm starting it now. It'll keep, frames are going up, times are going up. It was 8,000, it already went to 12,000, the quality. Keep watching the quality also of the video, okay? So first, it is still at 12,000, you know, whatnot, and the quality is very good. You can see it. So almost think about, you know, this screen size is almost like your of your the mobile phone nowadays, right? It went dropped down to 8,000. Did you notice a big difference in quality? Not necessarily when it went from 2kp to 1kp, 1080p, right? It's 8,000 again. And so we are right now at 44 seconds. Keep watching this information. It'll be pretty soon going to change. Very good quality. I'm pretty happy with it and whatnot, right? 52, 54 is still 8,000. Nothing changed. I'm happy with this. The quality is very good. And then, and pretty soon you're going to notice something. Just give a few seconds. It's coming up. And you notice that it's stalled. That means what happened, that the server did not send any packets to any segments to the client side. And so because it did not send it, so it couldn't do it. Suddenly you see that it dropped to 400 kilobit per second. Okay, it went to 200 kilobit per second, right? The quality dropped. Keep watching this one. And look, you can see from the screen the quality is not good. 200 kilobit per second, and keep watching it. Okay, you know, it's watchable, and what our network coordination is what is doing it. And then at least I'm not stalled anymore because of, you know, because of the network condition. I'm sending the lower quality video from the server at the request of the client, and so and that's okay. So keep watching it. Okay, 200, 200, 200, still 200 kilobit per second, 200 kilobit per second, and keep watching. It doesn't look like the picture is not necessarily too bad. It's still watchable, but I can see that it's not as high quality as before. And now keep watching. Suddenly it is going to change. Jump to 1,000, 4,000, jump to 8,000 very, very quickly, and 12,000. Okay, it's got it again dropped to 200. Okay, and it is stall again because of the situation, whatever happened. Okay, and then it went up to 12,000, suddenly jumped, and then it is in 12,000 and whatnot. Again, there is a small stop, and then finally we go to the enter of it. Okay, so what you see is that how the quality changes and whatnot. Yes, sir. All right, so now let's kind of go to the what we call is that the buffer idea. I mentioned that before. So let's give a simple illustration. Let's assume that each of same frame size in terms of time, 2 seconds. But here what happens is that because of the client is requesting it, they are of different resolutions. So to represent the different resolution, I gave this size in different sizes in terms of the rectangle. So this is the size of the buffer for right now, where the client is holding it. And these are the of different resolution the client requested. This is getting segment number 1, 2, 3, 4, 5. All right. And let's say it played out the first segment. And while it played out the first segment, it already received segment 6 and segment 7. That means this is emptied out. That means I have, at this point, my buffer is full. If my buffer is full, client will say that, hey, my buffer is full. I'm going to wait for a little bit before I actually request the server at all. So in that meantime, when you're waiting, if there's a network congestion there, that even if you then request that, hey, send me the segment number 8, because of network condition, it may happen that you did not get it back in time by the time you played out segment number 7. In that case, your buffer is going to be completely empty on the client, and you're going to have the stall that I illustrated earlier. Got it? Okay, so this is very important. Here's another way to illustrate it. So you look at the request and the response, the video client and the server, and you kind of look at it, each of our different video rate. So let me see, if I illustrate it, it's going to playing it out to the client and whatnot. And then see a different size, and it's going to be getting a new button, and then eventually it gets finished up. What I want to point out here are two things that's happening. One thing is that it uses what is called the adaptive bitrate algorithm, ABR in short, by the client to decide on it. And the throughput may be different because of the actual number of bits needed to code each of the segment actually. Secondly, remember I talked about the bitrate, you will see the bitrate. So bitrate doesn't mean the throughput is always going to be the same. It's very important to understand. The bitrate only says the signal level of each of them. There you will see that this is what is going on in terms of the different bitrate. It is at a higher rate, it drops it down, it goes higher, drops farther down, and like that is going to happen. Usually the throughput is going to somewhat follow the bitrate, but not necessarily. Here is another illustration. This time I'm purposefully using multiple clients to illustrate what is happening. Let's say you're a friend and you're watching a live event, sports or whatever. And your friend is watching on a laptop, you're watching on your mobile device, right? So what could happen is that your friend with the laptop may get here I have three, remember I talked about the table of information, I'm putting it out here. This is the highest quality, 5 megabit per second. This is the medium quality, this is the lowest quality. So I'm using only 3 resolutions to illustrate that. And so what you get it is that in this case, because of what happened or where the person is located, it got the lowest quality segment 1, medium quality segment 2, then 3, 4, 5, 6 at the highest quality. On the other hand, you, on your mobile phone, you got the lowest quality segment 1, 2, and 3. Only then you jump to medium quality 4, 5, 6. So actually, because of each one is facing different network condition, this is another reason why you can actually get the different quality that the client is going to fetch. And as I said before, earlier, MPD file is first transferred, based on that is going to fetch it, right? And I want to point out that each segment is like a URL. You know what an URL is. Where is the link, web link that we talked about? That's the official name of the web link. And URL stands for Universal Resource Locator, for those who are interested in it. So let me get a little bit into MPD file content in terms of what it is. As I talked about, it's an XML file earlier. It provides a bunch of different information. It says that what metadata, the playback duration, the segment duration, adaptation sets, video set, audio sets, subtitles, it may be there, that's also there. And each adaptation set could have multiple representation or resolutions I talked about. And you'll say the type of what is doing the audio codec and whatnot. So it's going to do that information will be there. Then the video parameter, height and the width. You saw that with that video clip I played before, and the frame rate. This information is there. Duration for each segment is going to tell you it's a 2-second duration or 4-second duration, or usually from between typically 2 to 15 seconds duration possible, but on a particular MPD file, it sticks to a particular duration as the standard duration for the entire movie. Recommended bandwidth, it might actually say it, and then each segment has a separate URL. I already mentioned that. You can go to this website and look at an example of an MPD file, or you can just search on the Google typing example MPD file, you'll find some information there. So I want to point out some segment sizes for different resolution and in a different way to illustrate that. So what you kind of see it here is that these are, I'm saying, remember in this particular one, I believe, I listed all the segment numbers from 1 to 150, and each one has a 3 different quality. Red is the lowest, and blue is the highest, green is the medium. And then each of the 2-second clip, for example, I think this one, 2-second clip, I can't remember now if it is 2 or 4 seconds, is coded on a bytes. So what I'm plotting this time is in terms of the byte, kilobyte, how many kilobytes is needed to be able to code that information, right? So what you find out is actually at this very beginning, this is the blue one is the height. It could be in the, pretty high there. Green one, you can see it here, and the red one, which is the lowest of this one. But when it drops on after a few segments there, it seems all 3 of them are very similar. Then it goes up again and goes down. You may wonder why this fluctuation happens and in terms of high and the lows about that. Sorry, something. Okay, high and the low of it. So the reason is that if there's a first fast action going on, sports or something like that, typically higher the resolution, you need more bytes to be able to encode it. If it is something like a very still, like for example, I'm standing very still, not saying anything, the number of bytes needed to code is not much different whether it is a high resolution or low resolution or medium resolution. That's why you see all of them similar at the bottom part of it, right? So it actually fluctuates there. And this is also affect that information I talked about earlier in terms of how that's actually the throughput can impact it. Because remember what I said about the throughput, transfer rate. Transfer rate is basically the time to transfer, and depending on the byte size. Remember, byte size now in terms of what the file size I talked about, and then the transfer rate. So the throughput is going to keep continuing. So now if I can look at the entire picture, here's a client, here's the server, dash client and a dash server. So MPD file is first transferred. And once the MPD file is transferred to the client, it's going to start then doing the throughput estimate. It's going to estimate the throughput, and then it is going to go from the client to request from the video segment. And this is the table I talked about. This is the highest resolution, medium resolution, low resolution idea. And it's going to say fetch whichever segment you want based on the client's telling you. And that's going to come to that here, the media module, and it's going to play it out. Okay, and this is the entire segment. Okay, so this is how the entire thing is going to work in terms of what we need to do. So buffer or temporarily for a certain duration at the client. I talk about wanted to avoid stall, want to keep as high quality as possible. This takes to what we talk about is call is the video quality of experience or QoE. How long does it take it to do the initial startup part? That means startup delay means that before, when you requested the movie, when it says buffering, before you start playing the first clip. And that one is initial startup delay. Buffer empty when it's the stall, that is also important. You don't like too many buffer empties or stalls during watching a movie. Quality change, how often the quality changes, it can be quite annoying if too many changes. And overall throughput is also important. Throughput means that how much megabit per second eventually you could get transfer. More bytes you can transfer entire movie, that means you've got an overall high quality. That's another way to. These are the four main drivers for the quality of experience. The initial startup delay, I want to quickly point out something very, very important here. The important thing there it is that for somebody watching a movie on Netflix or Amazon FIRESTICK or Amazon Prime, we are willing to wait a little bit longer at the beginning to watch to make sure the first clip is thing. So buffer can be a little bit longer. On the other hand, YouTube also uses, for example, a dash. For YouTube, the problem is slightly different. If a video doesn't play, the first clip doesn't play within, say, 2 to 3 seconds, because of our impatience with web page, you are going to lose. You think, oh, the video is not coming at all. You're going to lose interest in that. You might going to go click another video and stuff like that. So it is the amount of buffer, how you do it, the idea is same, but how you want to minimize the initial startup delay is different for YouTube than you are going to do for a regular movie that you watch over. You watch it over Netflix or Amazon Fire Stick. Good. So now let me talk about live video streaming. How what and what not is different or whatnot. Here's an example. What I did. It may not look very clear to you. It is about from a U.S. Open tennis, and it is the semifinal of a match between Pablo Carreño Busta and Alex Zverev. What I have in the left side is that I have the web page open to see just the score, just the web page open that instantaneously keep changing the score. This one, the black frame, is nothing but my iPad to where I'm streaming the movie through the internet, right? It's not movie, I mean, the match, I mean, the tennis match. you will know, I want you to pay attention to the score. I do not know how much you know about Tunis. It's not necessary, but the meaning will be important here. You will see these are called 3 sets. You'll see there, the 3 sets are there. Those 3 sets are same score. Then you look at here, you'll see 1 and 0. That means it's the 1 game in 4th set. And then you also see a score that is a 1 point, 15 point. If you look at it here on my video, on my iPad, you see this actually at 0, 0, exactly at the same point when I use my phone to take this picture. And it says add, that means it has an advantage. Carino Busta had an advantage at that point, and they are not matching up. In fact, this score that I got it through the web page is, looks like that more thing has happened. You know, you don't know how many more things had happened. So what I did was that I actually used a timer to measure it. So I say as soon as this score changes, I wanted to say when my iPad that score changes the streaming. And I'll tell you my result. So I already talked about the score. The result, started the timer, checked it, we did multiple runs. You know, I'm always an experimenter. I always test something multiple times. You know, something I learned when I did my physics class back in 11th and 12th grade, why you do measurement multiple times. And so what I found out is that by the time, the score I saw, by the time it got updated here on my streaming, video streaming, is delayed as long as 67 seconds, and on one case I saw it maybe 60 seconds. That means the buffer time, you know, it's a long delay. So if your friend is only watching your score on this web page, is going to know about that much faster than you're watching on your streaming video on your iPad or a phone. Okay, and so you know, so you might say, why is it so much of a 60-second delay? There are a couple of reasons for it. First thing is that many countries, actually, there's a purposefully delays done about 5 to 10 seconds, so that if there's no other bad thing said or whatever, that they can filter it out. That's the first thing. Second thing is that there is a time needed from the actual capture of the video to digitize it, create the MPD file that I talked about. Here, the segment I created, them dynamic MPD, they need to actually take care of, and everything. It takes a little bit of time. So you can say about maybe first 20 seconds goes for taking care of those things. So it's about 40 seconds of buffering is needed to be able to let you watch a quality, high quality video. Me watching on my iPad or smart TV, I'm happy with it because I am getting to watch the match in a very high quality, and so you sometimes trade off between the startup delay and the high quality, maintaining the high quality. That's different how you are going to do it for something like live video streaming than you will do, for example, a YouTube video. So adaptive bitrate algorithms are, there are many researchers have worked on it. We have also worked on it. Broadly, they're classified into 2 groups. One is the throughput-based algorithm. The other one is the buffer-based algorithm. I want to point out this, the dash, the MPD file, and the segments, and those things are standardized, not the ABR algorithm. It's purposefully allowing for the content provider to update your client device, client player software and whatnot, to actually update with a new and better algorithm. So throughput-based algorithm always decides on the rate adaptation based on the throughput. Buffer-based based on how much the occupancy of the buffer. That, remember the picture I showed about. And based on that, actually you're trying to do it. And after minimum buffer is filled, shift to buffer-based adaptation. You said, okay, I'm going to adapt quality, high quality, low quality. So then you can kind of look at it this way: buffer occupancy information, download the measure the rate and whatnot, and based on that you're going to estimate the rate and what it is needed, and then you are going to say, okay, I'm going to get this quality or that quality of the next segment size from the MPD file based on that. So now I'm going to give you a little bit of what I call as an engineering way to improve something from a delivery point of view. For example, different client devices. This goes back to what I said earlier about the client and the server. Remember, we always have this thing: client request this and the server provide response. This idea doesn't change even if you are doing a small video segment. Video segment will go still to the get that particular segment, will tell you what the segment number is going to transfer it and whatnot. Will do the content length, the video in terms of bytes, remember I talked about, and whatnot. And then it is going to say that it's a MPEG standard, and it's going sending that particular video. So your client is then stitching it together to play it out to you. So now go back to what I said earlier. Remember I said about the user agent? User agent is a very interesting thing. What I call is like a breadcrumb. It actually gives information to the server that what the client is about. So just to give you an example, here are some users as an example. If you're using a Chrome browser on Android is going to use a bunch of information there. A Firefox browser on Android will go to give you different information. Safari on a Mac is going to give you what information. And once you know this information, Mozilla browser for Windows is going to tell you this information. The server can then say, I know what the client device it is coming for. Based on that, I may actually give you a customized MPD file. For example, if you're on a smart TV, it basically gives you a hint that, hey, it must be on a very large screen. Somebody is watching it. They probably want a higher quality. I'm going to slow down the delay initial part for so that I can send more higher quality segments to the client to play it out. But if you're on a small handheld device, said, oh, it is a handheld device, is using this sort of a, I know what it is time. I don't need to give the highest quality because it's not going to be able to play it out. It does resolution is not there to be able to take care of it. So you can customize different MPD file for this purpose. So that's basically what I kind of talked about. This is possible to do it. Let's now, having said that, move to 360-degree video that I mentioned to you. First thing is that this video of a 360 video is sometimes known as immersive or spherical videos. They are all 360 direction. It's recorded in an omnidirectional camera, a special camera you did, and sometimes dedicated camera at multiple lens embedded into the device. You can also do it. And the viewer has the control over the viewing direction. This is where it is different. For example, right now you are seeing me on the screen here, right? You're only seeing only one view, single view. This is a standard flat video view of it. In a 360-degree video, you may have an option to see me from one angle. From this angle, you wanted to see me what I'm doing. Or almost, we say, what is behind me, you might be able to see it. It's almost like a three-dimensional aspect also captures it a little bit, right? And we usually said that you have what 360-degree, so you can have a 3 degrees of freedom or 6 degrees of freedom that is possible. And sometimes you get a goggles like that nowadays. You can buy those 360-degree thing to view it. And obviously, you're watching something at a live event or whatnot, you're going to do. So here's an example. Here's a basketball game, and you're watching it on a 360-degree video. It is flattened out just for the purpose of being able to show what is usually is curved. And if you're watching this as somebody interested in a basketball, you are very interested in this player who has the ball in it. Now, your son who's sitting next to you went to the basketball game, very young, not interested in it. He is really interested in looking at what is happening with the people here, right? So he's using a 360, you're using one, you're paying attention to the ball, he's paying attention to that one. He's going to get that particular focus much, that's what it is interested in. So he can actually look at that. That's what 360-degree video allows you to do. Now, we can do very interesting, since each of us have something different we're interested in looking, you can now say that, hey, does it make sense to have a this particular two-second clip to have the same resolution for all of it? Because each of them, we're going to watch something different. So this is where one thing you can do is what is called, you can grid out into, let's say here it is 3x3 grid of the entire screen for your 360 video. And then you can break it out this way. If I'm interested in this, and maybe the ball may move here, my region of interest is actually only these two. This is what it is. Your son, who's watching the people is interested there. So we don't need to get, it's the same resolution. If we can break this view into like a 3x3 grid. What that means is you save a lot of bandwidth in terms of transferring it to the devices, if we know that, based on the region of interest. This is still an area of research into what's the best way to optimize it to deliver it to you. That standard now has been extended to be able to allow this 360-degree video, because you have to give certain additional information like the grid information and whatnot, and so that you can actually break it down into what is called a smaller sort of a clip and whatnot, right? So that's basically why I wanted to give you. We did some work on that. Finally, I want to point out what I briefly earlier talked about the adaptive bitrate algorithm. And so what is research in video streaming? Obviously, devising a new algorithm. But devising a new algorithm by itself is not sufficient. You have to somehow prove that your algorithm is actually better than other algorithms. So then you have to do some sort of a system. You have to build it to be able to test it out. And you have to test it out under different conditions, not always an ideal condition. There may be some interruption or some other situation happening, and you want to measure it and then compare who, in terms of the quality of the experience, if your scheme is doing better than another scheme. Not only that, sometimes what you do is what is called a subjective approach. You get people to watch it, and then they give a score between 1 and 5, where 5 is the highest score. It's called the mean opinion score. If you look at the with multiple people looking at it, you kind of look at that information and then see what they say. They cannot separate it out for number of stalls and information, but they give you a quality, watching the entire video, what they actually observe. This is where the collecting the quantitative metrics through a client device is actually very important, because you get the quantitative information, then say how many stalls I had watching a 2-hour movie, how many quality switching happened in the resolution during that time. You can actually calculate those things out. There have been a lot of people have done research in the area. We are not the only one. We have done some work on it. I just wanted to list out a few papers here. Those who are interested, you can contact me, and I'll be happy to kind of. So this kind of goes to the end of what I wanted to talk about, and I believe there are a few questions, so I'm going to answer those questions that I got from the audience. So I'm going to stop the screen sharing and going to go, okay, and I have a couple of questions. One question is that 360 live streaming versus 4K live streaming, which one is harder? 4K live streaming, it is still a flat information. Amount of bits needed to code 4K is definitely more than what you need it for 200K, for example, sorry, 200 kilobit per second that I talked about, right? So you wanted to know that in terms of the number of bits, it is much more bulky. But 360-degree video is different. Remember, it has to look at a different perception of looking it around, right? So you're not giving one flat piece of information. You're giving angular information. I talked about 6 degrees of freedom, right? So you're going to actually transfer a lot more data, unless you can optimize somewhere. Second thing is that you need a much different, better intelligent algorithm at the client side to be able to play it out the better way. So there are a lot more challenges and exciting that makes it happen. That's a very, very good question. Second question is that, can we make 360-degree video with our phone? Currently, I do not know of any phone that can actually allow it. You basically need to have a camera that can do 360-degree video, right? Capturing it. So the phone cameras right now not quite there yet, but I won't be surprised it is going to happen in the next few years. So that's what we wanted to kind of pay attention to that, right? And see what is going to change and whatnot. One other question is that, how would the adaptive algorithm change when we move towards 5G and bitrate actually improves? Very good question. So we have two interesting challenges coming up. 5G is the new wireless standards coming up that's going to be deployed pretty much very soon. In some countries already deploying, many places going to deploy. Many countries right now between 3G and 4G. 5G is going to have the capacity is going to increase, so you're going to have a much better thing. There are two things to think about. When we talk about your mobile device, you're watching it on a 5G network. That doesn't mean the server is located at the edge of the 5G network, because 5G network is sometimes connected to a fiber optic network that actually connects to some cloud data center where your video is stored. So eventually the end-to-end transfer rate matters, so where the congestion is. Just having a highest quality 5G network doesn't necessarily mean that you are going to be able to get the best quality video and whatnot, right? So that's one part to the question. Second part to the question is that, having said that, you still wanted to say that, can we do a better algorithm than what it is there? And this is also why once in a while when you see that, oh, you get a message saying that you need to update a video player or something, the software update, you're getting it in a Google Play or iTunes store and whatnot. So you get it, download it, and usually when they say bug fixes and stuff, they don't say. Sometimes they will say algorithm improvement and stuff like that, and they do actually look at it and try to improve that. So with that, I think I have covered what I wanted to cover. I thank you for your interest, and looking forward to doing more webinars like that. Not only that, I'm going to bring in other speakers who have their own expertise that I obviously do not have expertise in everything. So they will be able to give you different information, and just look for this webinar announcement for the website I mentioned earlier. And thank you again for watching and listening.